Hey there, welcome. Today we are diving into something that trips up so many of us, decimals. Yeah, that little dot. We see it everywhere, right? With money, with measurements, but it can cause so much confusion. We're going to get into the mental traps our brains fall into, and you'll see why they're so predictable.
Okay, so let me ask you a quick question. Have you ever looked at two decimal numbers, maybe something like 0.7 and 0.65, and had to stop for just a second to figure out which one is actually bigger? If you're nodding along right now, trust me, you are not alone. It's a classic mental hurdle.
I mean, it is so common. There was a study that tested middle schoolers on these exact concepts, and guess what their average success rate was? A measly 40%. That means most of the students were getting tripped up. And this isn't about just making random mistakes. There's a real pattern here. So what's actually going on in our heads?
Well, this gets to the heart of it. The key isn't that people are just bad at math. It's about something called a misconception. The study's term for it was kavram yanilgasu, and it basically means a belief that feels completely logical, totally right, but it's scientifically wrong. We're not talking about simple slip-ups, we're talking about predictable mental traps our brains build for themselves.
So to really get a handle on these decimal traps, we've got to take a quick step back and make sure we're solid on the foundation. So let's do a super fast recap on what a fraction even is.
At its core, a fraction, or kasir as it's called in the source material, is really simple. It's just a way of talking about equal parts of a whole. You know, like half a pizza, a third of a cake. It's all about splitting something into equal chunks.
And these fractions come in a few different flavors. You've got your simple, everyday fractions where the top number is smaller than the bottom. Then you have improper fractions where the top is bigger, meaning you have more than one whole thing. And of course, mixed numbers, which are just a whole number chilling with a fraction. All right, foundation is set.
Now for the main event. Let's get into the most common decimal traps that the research found. This is where our brain shortcuts, which are great for whole numbers, totally backfire on us when it comes to decimals.
You know, the biggest problem of all is the decimal point itself. A lot of students see it as just a separator, kind of like a comma, between two separate whole numbers. But its real job is to be a big signpost. It's shouting, hey, everything that comes after me is a part of a whole, something smaller than one.
So with that in mind, I want you to look at this classic question. Which number here is the biggest? 0.5, 0.50, or 0.500? Now don't overthink it, just what's your first gut reaction?
If your brain immediately went, well duh, the one with more digits, then you've just fallen into the number one trap. And look at this data. Almost a quarter of students did the exact same thing. It makes sense, right? With whole numbers, 500 is way bigger than 5. Our brain is just applying an old rule where it doesn't belong.
But here's the thing, they're all the same, exactly the same value. They all just mean 1/2. Think about it with money. Is half a dollar any different from 50 cents? Nope. Adding those extra zeros to the right of a decimal doesn't change a thing. It's just a different way of saying the same amount.
All right, ready for another one? This one's a real brain bender for a lot of people. Take a look at these two numbers, 0.23 and 0.24. Do you think you can find a number that lives somewhere in between them?
I mean, check this out. It's pretty wild. A whopping 90% of students either said, nope, there's nothing there, or just didn't answer at all. Their brain just defaulted to what it knows about whole numbers. There's nothing between the number 23 and the number 24. Case closed, right?
Wrong! In the world of decimals, the space between any two numbers is infinite. You can always zoom in further and find another number, like 0.235. That fits perfectly. So does 0.231 or 0.2399. You could literally keep adding digits forever. It's a concept called density, and it's a huge difference between how whole numbers and decimals work.
So we've seen how just comparing decimals can be tricky, but you know what? It gets even weirder when we start trying to do basic math with them. Let's look at the hidden traps that are just waiting for us in multiplication and division.
I mean, think about it. We spend years learning a super simple rule in school. Multiplication makes numbers bigger. 2 times 4 is 8. 10 times 5 is 50. It just makes sense. It's a core belief. But is it actually always true? Well, here's a classic math myth getting totally busted. Students were asked if 12 times 0.247 would be bigger or smaller than 12. And a lot of them just went with the old rule, assuming it would be bigger. But look at the reality. The answer is around 2.96. It got smaller.
And here's why. When you multiply by a number that's less than 1, you're really just taking a piece of the original number, so of course the result is going to shrink.
And you guessed it, the same exact mental trap happens with division, just in reverse. When students were asked to divide 12 by that same decimal, more than half of them predicted the result would be smaller. It's that whole number brain kicking in again, thinking that division always means chopping something up into smaller bits.
But the total opposite is true. Think of it this way. When you divide by a number smaller than 1, you're basically asking, how many of these tiny little pieces can I fit inside my original number? And the answer is, a lot. So dividing by a decimal between 0 and 1 will always make your result bigger.
Okay, so we've torn apart these mental traps. We've seen how our intuition can totally lead us astray. So why does any of this matter? Why is getting this right so important? Let's put it all together.
So let's boil it all down. Here's your cheat sheet for avoiding these common traps. 1. The decimal point isn't a separator. It means here come the parts smaller than 1. 2. More digits do not automatically mean a bigger number. And 3 and 4, when you're playing with numbers less than 1, multiplication shrinks things and division makes them grow. Just being aware that these traps exist is half the battle.
But here's the real secret, and this is so important. This isn't about just memorizing a new set of rules. It's about really understanding why the rules for decimals are different in the first place. It's about knowing when your whole number logic works and when you need to switch over to fraction-based thinking. That flexibility, that's what's known as real number sense. And that leaves us with one final big question to think about. When we approach math, are we just blindly following a set of memorized rules like a recipe? Or are we actually taking a moment to understand the ingredients, what the numbers and the symbols truly represent? The answer to that question can make all the difference. Thanks for digging into this with me.